In this video, I will explain narrow band rejection filter and notch filter. The characteristic shape of its frequency response curve is narrow. Shape of its frequency response curve is narrow. The stop band of this filter is very narrow. This is the stop band. This one is the stop band. This one is ideal case. This one is stop band. The stop band of that filter is very narrow. Narrow band rejection filter. The typical application of this notch filter is the rejection of a single frequency FN, such as 50 Hz power line frequency hum. First point, important point is the name of the filter. The name of the filter, that is notch filter. Why it is called as notch filter? Is due to the characteristic shape of its frequency curve. This is the frequency curve, gain versus frequency. The stop band of this filter is very narrow. The stop band of this filter is very narrow. Very narrow. This is the stop band. The typical application of this notch filter is the rejection of a single frequency. This is the single frequency, notches the single frequency, that is such as 50 Hz power line frequency hum, HUM hum. Particular unwanted frequency can be eliminated using this filter. Particular unwanted frequency. Particular unwanted frequency can be eliminated. By using this filter. The passive circuit used to obtain the notch filter is the twin-T network. This is a passive circuit. Only passive elements are there. Resistance. Twin-T network means 2 T networks are connected parallel. The passive circuit used to obtain the notch filter is the twin-T network. One T network consists of R and 2C. Another T network consists of CC R by 2. These two networks are connected in parallel. It consists of two TV networks. One consists of two resistors and a capacitor, while other consists of two capacitors and one resistor. The notch out of frequency is the frequency at which the maximum attenuation occurs. This is given by Fn. Fn is equal to 1 by 2 pi RC. Generally, the characteristic shape of this curve is ideally this one. Fn. The notch out frequency is the frequency. This is the frequency at which the maximum attenuation occurs. This is the attenuation band. The maximum attenuation occurs. This is given by Fn is equal to 1 by 2 pi RC. This is the passive twin-T network. The disadvantage, some disadvantages are there. The value of Q are figure of merit. Figure of merit for this passive network is very low. Hence, an active notch filter which uses twin-T network preferred in practice. Quality factor is very low, less than 10. Selectivity is also poor. Selectivity is poor. Therefore, unwanted frequency Fn is not rejected by using this passive twin T network. Coming to active twin T network or active notch filter. To design a notch filter to eliminate the specific notch frequency Fn, choose the capacitor C less than or equal to 1 microfarad. Therefore, this Fn is equal to 1 by 2 pi RC. The capacitor filter is chosen such that that value is equal or less than or equal to 1 microfarad. This is the active notch filter is a combination of passive twin T network. This one is a passive twin T network, entire one, and plus voltage follower. That is, this is the active network. Combination of this one is a passive twin T network plus active network. That is the voltage follower. Combination of these two. This circuit is used to eliminate the unwanted frequency. That frequency is represented by equal to 1 by 2 pi RC. The notch out frequency. That is the reason we use the Fn. The notch out frequency is the frequency at which maximum attenuation occurs. Maximum attenuation occurs. Maximum attenuation means unwanted frequency is completely removed by using this one. Next, calculation of notch out frequency. Calculation of notch out frequency. Notch out frequency Fn. This one we use a twin T network. The resistance R here. One more element is there. That is the resistance R and 2C. This one is 2C. Another twin network CC R by 2. CC R by 2. Another one is here. C. See, these two are connected here. These two are connected here. They are directly connected. Here there is no connection. One more connection is there here. The dot indicates some connection. This one is R by 2. These two are connected to ground here. Here V in is applied. V in is applied. This one is V in is applied. Next one is here R is voltage follower is used here. Voltage follower plus minus here. Output is V0. This is also connected to ground here. V0 here. V0. The output of that this emitter follower is connected to this is one. This is like that. This is the emitter follower circuit. This is V0 and voltage follower or emitter follower. Here we use some node voltages. Here A, here B, here V0. Apply node voltage at A, B and inverting terminal, non-inverting terminal of the op-amp. First one is here. Apply node voltage at A. Apply node voltage or node a nodal analysis. Apply nodal analysis at point at node A. At node A. That is VA into the resistance connected to this node are R and R. Consider admittances 1 by R plus 1 by R 1 by here 1 by 2 CS. 1 by 2 CS means plus 2 CS. Adjacent node voltage is minus V0 by R. Another adjacent node voltage is Pin minus Vin by R is equal to 0. This is the equation number 1. Equation number 1. Solve this equation. VA 2 by R plus 2 SC minus V0 by R minus Vin by R is equal to 0. 2 VA 1 plus SCR 1 plus SCR minus V0 minus Vin is equal to 0. This is the equation 1. Next, apply nodal voltage analysis at point B. That is VB into 1 by CS. This one is 1 by CS. This one is 1 by CS. 1 by CS plus 1 by CS. And adjacent node voltage is Vn by 1 by CS minus V0 by 1 by CS. One more is there, R by 2. That is 2 by R. Apply nodal analysis at point B. Apply nodal analysis at a point B. That is VB into SC plus SC plus these are the capacitors. C and C. Impedance of that capacitance is 1 by CS, here 1 by CS. Consider 1 by admittance. 1 by CS is here CS plus CS and 1 by R by 2. That is 2 by R. 2 by R plus 2 by R minus here minus V in into 1 by CS minus V in SC minus V0 SC is equal to 0. Simplify this one. Simplify this one. VB here 2SC plus 2 by R. 2 is common term. SC plus 1 by R minus V in SC minus V0 SC is equal to 0. Here 2 VB SCR plus 1 minus V in SCR minus V0 SCR is equal to 0. This one is equation number 2. Coming to equation number 3, apply nodal analysis at this point plus non-inverting terminal of that op-amp V0 into these are the this one and this one branches are connected V0 into 1 by R plus 1 by CS minus adjacent node voltage is here VB minus VA by R minus VA by R and minus VB by 1 by CS. This is the third equation. Apply nodal analysis. Apply nodal analysis at a non-inverting terminal of op-amp. non-inverting terminal of the op-amp. That is V0 into 1 by R plus 1 by CS. 1 by R plus CS minus VA by R minus VA by adjacent node voltage is equal to minus VA by R minus VB by 1 by CS. That is VBCS minus VBCS is equal to 0. That is we use LCM V0 into 1 plus SCR minus VA minus VB SCR is equal to 0. CR is equal to 0. Here VA and VB are there. From the first equation, 2VA into 1 plus SCR is equal to V0 plus Vin. V0 plus Vin. From first equation, first equation is 2VA 1 plus SRC is equal to V0 plus Vin. Therefore, VA is equal to V0 plus Vin by 2 into 1 plus SRC. From second equation, VB is equal to SCR into Vin plus V0 by 2 into 1 plus SCR. VB is equal to from the second equation, from the second equation, 2VB 1 plus SRC is equal to SCR Vin plus V0. Therefore, VB is equal to SCR Vin plus V0 by 2 into 1 plus SRC. These two VA and VB are substituted in that expression. Third expression. This is the third expression. Write down the third expression. From third expression, is V0 into 1 plus SCR minus VA minus VB. SCR is equal to 0. V0 into 1 plus SCR minus VA. VA is equal to V0 plus Vin by 2 into 1 plus SRC minus V0 plus Vin by 2 into 1 plus SRC minus SCR VB is SCR into SRC into Vin plus V0 by 2 into 1 plus SRC is equal to 0. LCM, taken LCM. V0 into 1 plus SRC 2 into 1 plus SRC minus V0 minus Vin minus S square C square R square S square C square R square Vin minus S square C square R square V0 is equal to is equal to 0. Here V naught into multiply these two, 2 into 1 plus SRC plus SRC plus S square R square C square minus 1. Another V naught is minus 1. Here another one is minus S square C square R square. V naught is completed. V in is bring out here. V in, another V in is plus V in S square C square R square. V naught into 2 plus 2 SRC means 4 SRC, 2 S square R square C square minus 1 minus S square C square R square is equal to V in 1 plus S square C square R square. Therefore, V naught by V in is equal to 1 plus S square C square R square by 2S square R square C square minus S square R square C square, that is S square R square C square plus 4 SRC. 2 minus 1 is plus 1. Plus 1. Here 1 plus S square C square R square by common term is R square C square, that is S square or SRC by R square C square plus 1 by R square C square. This one is my divided by this S square C square R square by S square C square R square, that is S square 1 by R square C square by S square R cancel, C cancel, 4S into 4 by plus 1 by R square C square. This is the gain of the notch filter, band elimination filter, that is A. Compare this, this one is with standard expression. A is equal to A naught into S square plus omega naught square by S square plus omega naught by Q into S. 1 by Q is alpha plus omega naught square. Omega naught square is 1 by R square. Compare these two. This one and this one. Here we use emitter follower, therefore A naught is 1. Here 1 into this one. A naught is emitter follower, the gain of that emitter follower is 1. Omega naught square is 1 by R square C square. Omega naught is equal to 1 by RC. Omega naught is 2 pi. FC is equal to 1 by RC. Here notch out Fn. Therefore, Fn is equal to 1 by 2 pi RC. This is the notch out frequency. The notch out frequency is the frequency at which maximum attenuation occurs. This is given by Fn is equal to 1 by 2 pi RC. This is the explanation of that notch filter or band elimination filters.